hold on. So this is what you want to start with, is this one?
Okay, so what exactly is the product?
Well, NetGauges is a programmable sensor unit that can interface to a variety of different types of sensors and provide live instrumentation displays and active control. So if the temperature were to go above a certain threshold, you can call an action and have it turn something on or off, or send a message out over the cloud to SMS or email, or activate another cloud service based upon that. So the key behind NetGauges is this interface unit that has Ethernet, wireless, or cellular connectivity, as well as local area network connectivity, which is CAN bus, J19, NEMA 2000, and 1703. So we can connect multiple units together, and at the same time, it can be a gateway into cloud services. I think this diagram gives you an idea of the types of inputs that are available on this unit. You got your standard 12-volt power coming in. You have another connector down here, which has got dual tachometers on it, so we can monitor rotational information. It's actually got 3 tachometer inputs, typically a port starter and a generator, or any other rotational input. This other connector harness, this third connector harness, has a variety of voltages and other sensors. Could be engine temp, oil temperature, oil pressure, amperage, fuel levels, just a generic input. I'll show you in a minute. You can actually reassign these inputs to set up whatever sender you connect up to each one of these harnesses. And then this fourth connector harness is a combination relay drive and or output, binary output signal that can control a switch panel or a set of relays. So these can be the actions you can assign based upon sensor rings coming in from this other sensor harness. So this gives you a feel that we're looking at about 28 sensor inputs this unit can handle, and it can control up to 12 sensor outputs or relays.
So what sort of senders can it deal with? Analog, digital.
Let me bring up a list of the types of send that we can interface to. There we go. So this gives you an idea of the types of senders that we can connect up to this unit. So standard VDO Pro style resistive temp senders, standard VDO style pressure senders, anywhere from 30 psi up to 600 psi. Obviously, a variety of tachometer types of inputs, whether it be a Hall effect magnetic inductive flywheel or the standard camshaft style sensor. Fuel flow monitoring using standard off-the-shelf flow meters. These are inductive amp senders. It's got dual exhaust gas temperature inputs for doing K-type thermocouples. Can do boost and manifold vacuum pressure. Can also do high int manifold pressure for performance style engines. Cylinder head temperatures, wideband O2 sensors, high-end pressure sensors up to 40,000 psi. So on, you can kind of get an idea here.
Yes.
These all are direct connect up to the unit and can be programmed in to fit whatever type of system you're trying to put together.
Okay.
So
So
the main thing about how this works is you've got your interface unit, which is your direct connection to your log sensors that you can pick and choose and set up how you need them. And then it can network over a local network inside the facility that it's connected to using Ethernet, CAN bus, or wireless technology. And with that local network, you can access the instrumentation using a standard web browser. So with a web browser, you can just set up a set of webs and go in and view gauges that way. The step that you have when you have local area network connectivity is that you can also bridge to a router, and if that router has access to the internet via cloud services, then this same data can be replicated over on our cloud servers. These servers are run on a cloud-based architecture that's been set up to handle automatic pushes from these units. But not only have local access to the information, but you also have global access using the cloud-based services. Of course, cloud-based services, what happens then is you can do 24/7 data recording. You can have active and metric processing, which means that we can actually analyze the data stream coming in real time and perform event actions based upon alerts and alarm thresholds.
So if we had an overpressure situation taking place, we'd receive a notification via some sort of internet connectivity or phone, and could then either ignore it or create an action to automatically take place or to manually be overridden to take place.
It can be done locally and via the cloud services. So locally, we have a Windows-based program that is used to configure the unit, and with this program, basically you would assign your the functionality of your different inputs. So in this case, these are all the inputs that we have access to on those sensor inputs, and so we've simply just typed in whatever names you want to those units or to those inputs. And then for each one of those inputs, we have a calibration table that's used to map the inputs into real values. So in this case, we're looking at a tank sensor for fluid levels. We're mapping it to full at 100% and empty at 0%. And so these tables can be assigned to all the different inputs, and that gets the ability to create trigger points. And the trigger points are set up in this threshold table where basically if I want to have a over voltage alarm, I could just come in and dial in at what point I want the voltage trip to occur at. So in this case, 13.4 volts. And then set up the action that's going to happen as a result. So as far as the unit itself, simply alert via a common alarm output, can turn a relay off. In this case, it can turn a latching relay on and off. And actually add another analog output, so that if you have one input that if you go over temperature, you want it to turn something else off, or actually set a voltage output on another system, you can assign those. So that's handled by the unit itself. So this would be a closed-loop system where you don't have internet connectivity for these actions to occur. But on a global scale, we can actually set up a cloud-based service to do the thing. So based upon this diagram where the unit is transmitting live information to the cloud service over its existing network connectivity, we can go to our cloud portal webpage and set up various actions to occur. So in this case, I have a switching unit that currently is set to generate switching events. And here I can actually go ahead and pick the events that are live off this unit and pick an action item that I want to activate. So this is where on a cloud system, if I have an over temperature condition, I can tell it to send me an alarm email, in which case it'll go ahead and give me the temperature thresholds and send it out to a bulk email address. You can do the same thing with SMS messages and or text messages. In addition, you can actually have the cloud take that over temperature situation, send a switch on or off command to another NetSmart unit that will actually turn something on or off based upon the cloud command. So that unit that's turning on and off doesn't have to be local. It can be located anywhere on the globe that has internet access, and it's respond to an alert condition from one unit being activated and distributed via the cloud service to other units. And we can also do lighting events. So if you want to have emergency lighting come on in case of an over temperature in an equipment room, they can actually start blinking the lights or changing light colors based upon those conditions. And this is set up on a cloud service, so it's available to all registered users and all devices that are registered.
So once the data is stored, can be stored locally, but it can also be stored on the cloud for analytics by let's say maybe other branches or other divisions of a company, or and or locally it can be viewed and analyzed. So you're storing all this data into the cloud for future reference.
Yeah, so as long as you have cloud access, the data can be constantly pushed to the cloud service. We do have store and forward, which means that if you don't have cloud service temporarily, it can hold data locally until cloud service is available and then push its archive up to the service. So you really do get a continuous feed. It's very good for mobile assets. Assets are moving in around, in and out of cell coverage, for example, where you want to have continuous tracking. But the main thing is we're simplifying the acquisition and putting most of the decision making up on the cloud service, because that is much more flexible and much easier to roll out different changes and or develop new applications. So this screen is an example of one of the things you can get with the cloud service. This is a dashboarding service that's currently taking live information from one of our remote sensor units. In this case, it's recording wind speed and wind direction and barometric pressure and temperature. And so we're getting a couple of things. We're getting instantaneous information here. So this is the current conditions at this geographic location here on the Oregon coast. And this is also historical information. So this is wind information, air temperature information over the last 24 hours, for example. And this is actually being used quite a bit now on news stations and their monitoring vehicles. So it has an application just for creating a branded user portal that the viewers of those news stations can go in and see local weather information that's being sourced by the news vans when they go out to the field.
Okay. Now, how about different looks and
here's another example of same system set up to do combination of active energy monitoring and actually active control. In this case, it's set up to monitor the electrical panel in a residential facility. And right now we have some inductive current clamps set up on here, and looking at these different circuits going on, which right now isn't very interesting because right now most of these circuits are off. But it turns out this particular circuit right here is a circuit for a hot tub. So we can see that on April 27th, that tub came on for a period of about 20 minutes and did its heat-up cycle. And here is another graph of a heater in an office space, so a space here in an office space, and this gives you an indication of how often the heater has come on, how long it stayed on, and so on and so forth. So kind of get a active energy use and as well as a historical energy use.
How about if I were monitoring if I was monitoring, let's say, a generator?
That would work exactly the same way.
Or an engine.
It's the same type of. Here is another example of a parking lot that this is actually being used to control the lights in the lot. And there are 3 different zones that are set up with a switcher system that's built into our unit, part of our relay systems. And what's interesting about this is that it actually is the cloud that is controlling the lights. So if I go back and pull this, this is actually the cloud setup that is being used to run these lights right now. And so here, what we're doing is we're actually monitoring and looking at energy being used by the lights, so we can tell the voltage and amperage that's being drawn. And we can also control the lights. So in this case here, what we are doing is going to set up a control algorithm. So we're going to turn one of the relays on, and we're going to base it upon an event. And the event is in this list here. So what we've chosen a remote unit somewhere in the world based upon its address, and determined that we want to do a switch on event, that we want to define where that box, what time zone that switch on event is going to be based on. And then we can pick the algorithm to determine what's going to decide turn on or off. One algorithm, for example, is if the min ambient lighting by a photo center, if the minimum value is below a certain threshold, we can turn it on based on that. We can turn it on based upon a one-shot daily timer interval, or in this case, based upon current sunrise and sunset values that the cloud provides based upon the geographic location information. So in this case, we're setting a trigger event that actually is what is turning these lights on and off. And right now what we're seeing is the lights are drawing energy because they're currently actively on. In fact, this bright here, and the fact that it says on, means that right now the lights in that parking lot are indeed on. This graph shows me what time of day the lights came on and when they came off over the last week. So I know the lights have been coming on and off on schedule over the last week, and I also know that lights currently are on at this particular moment. The colors are stacked because there's 3 different parking zones being controlled by 3 different relay banks. And so we know that all zones are on because of the amount of energy or how much current each one of these zones is drawing. So we know each zone is drawing the correct amount based on the light in that zone. And so therefore we know that all the lights are on and not just some of them are on.
Okay. Do you have one for an engine? Just an idea of a screen?
I probably have one that's active at the moment. Some of these, because these are based on 24-hour periods, if this engine wasn't online in the last 24 hours, and it's not going to show up on this chart.
Okay. So can you design your own? I'm guessing you can design your own inputs and but you can design your own dashboard.
Design your own dashboards. I'll just take one of these examples here. So here's a weather page because we got an active weather feed coming in. So right now this this air temp is set up as just a numerical value, but let's say, for example, I wanted to go ahead and take and just change one of these. So I'm going to add a new data page, a new field to put something in it. And so instead of having a numerical air temperature value, maybe I want my air temperature to be on a form gauge with maybe 0 degrees Fahrenheit to 120 degrees Fahrenheit. So once I create a spot for it, I can go ahead and add a new type of renderer. So in this case, we're going to set up a gauge as a renderer. And what we need to do is we need to pick what the source information is. So in this it's going to be the air temperature. Units will be in Fahrenheit. We want the minimum to be 0 and the maximum to be 120. And then I'll go ahead and set some colors. And there you go. Now create a gauge for air temperature between 0 and 130 degrees, and right now it just so happens to be 59 degrees here.
Yeah.
So, once you have a gauge, then you can basically rearrange these and stack them in different places. There's about a dozen different types of widgets that you can pick and choose from and construct your dashboards with. These are all cloud-based, so basically once you get in there, go ahead and type in the API key, which is the secret key that gives you access to the data from that device. Once you type that key, and these lists populate out with what information that device is outputting. So basically you get just the information that's available, and that gives you access to anything coming out of that unit.
Okay. Well, great.
One thing
go ahead.
Is if I go back to my other screen here, is this allows you to aggregate multiple devices at one time. So if I go back to this parking lot screen, for example, these plots that show up here are not coming from one device, but they're coming from 3 different units. And so what we've done is you identify the unit up here. So there's an AC status from one unit, AC status from another unit, separate unit. And these can be located anywhere in the world. But this dashboard aggregates that all into one screen. So you don't have to have a screen for each unit. You can put multiple units on the same screen as an overview of the system.
Okay, I get that. All right. Well, great. Now, just one in closing. The I guess the applications are basically endless. From what I read, there's upwards of 300 or so algorithms that have been used or tested in the past.
Yeah, we've covered quite a few. I mean, obviously any mechanical thing that has a sensor on it, everywhere from pressures, boost, fluid levels, temperatures, retinal information. We got an interesting one actually here that is a hydroelectric dam that they actually are using this system to monitor the sediment buildup in the spillway in order to not have sediment come into the turbines when they're generating electricity. And so this is actually the current depth of the spillway intake into the turbine generator. This is a historical graph of how much the sediment's been building up, changing. And unfortunately for them, over the last day, that's really been changes. This is a week period here. Measurements are being collected over a period of weeks, so it's been fairly steady over the last week. But this is critical when it rains a lot because these values can start to change, and that the power plant down in order to flush the spillway. So, and they want to make sure they do it before sediment starts coming into the turbine instead of after. So this is actually being used live right now on a hydroelectric dam up here in the Cascades. The input on this is a sonar transducer. So, we were able to really easily adapt to standard sonar system and use that in order to measure water depth. So it gives you kind of a feel for the flexibility of the system and how it is to adapt to other applications.
Well, for far distant applications, such as I know there was one you did that was for oil, and it was an oil well or gas well or something. I don't exactly remember which one, and also some vessel activity on the open seas, where I guess they can use you can transmit packets of data via some of the newer satellite technologies.
Yeah, what's nice about the system is that, here in this diagram, we're showing a network router which might access the internet over a DSL line or in this case, maybe a satellite internet connection. But then could also be replaced with a standard short burst message transceiver, and that could be used as well for transmitting back and forth. Whatever this piece of equipment is determines what the network connectivity is. So our unit itself provides the connectivity solutions to your internet gateway devices, the things that actually get you access to the internet, which could be RS-232, it could be CAN bus, Wi-Fi, Ethernet. We also offer direct cellular connections that use standard cellular networks if they're available, or in your example, some sort of satellite-based internet service and/or short burst message satellite service.
Okay. Well, I guess if that's a good short introduction. If there's anything you want to close with, or we can get a little more detail at a later time.
Well, I think that the key thing is that we have a generic sensor unit that takes care of handling the collection of the sensor data, and it does minimal onboard decision making. It's best to let the cloud service do most of the decision making because that gives it its flexibility. And then in addition to that, the mating product is the switch units that are set up to activate things based upon events that they're being told to monitor.
Okay.
There it is. Such units, work pretty much the same way. This unit has 8 15 amp circuits built in. It's got another 4 external drives, so it can do up to 12 circuits in one unit. And it's connected to the internet, and the cloud service will actually send it switching commands to turn things on or off, so that one of our sensor control units can detect the temperature threshold, and then this unit can actually activate equipment based upon that event. And then the third piece of the product line is the lighting control system. So these work similar to switching units in that they can activate various lighting circuits. In this case, either change the lighting level itself, the brightness of lights, and or do color RGB type style lighting. So if you had an over temperature event, you wanted the temperature or the light colors in the room to change to indicate a warning condition, then you get these units together using the cloud services to achieve that end goal. So there's kind of a complete integration of not just the sensing side, but what do you do once you have an alert event that you want to have something actively occur as a result.
Okay. All right. I guess thank you very much.